In problem 22, we're asked to use algebras to solve the equation. So when you're asked to solve, factoring is the fastest way, but it does not always work. Quadratic formula and completing the square will always work. So it's going to be your choice in how you solve, but you must use algebra to verify that you have the correct answers for x. So I'm going to start by seeing, can I factor this? That's going to be my choice. Could you use these two? Absolutely, you could use the other two choices. So first I look here and I go, okay, smallest number is 18. What goes into 18? 1, 2, 3, 6, 9, and 18. And I'm going to ask myself to start with the largest numbers. I'm starting with 18. And ask myself, do these numbers nicely divide into 32? So what I mean by nicely is when you divide it, you get a whole number. Well, that doesn't work. Let's try 9. Oh, that doesn't work. Let's try 6. That doesn't work. Next, I'm going to try 3. That doesn't work. And try 2. Oh, 2 works. 2 is the largest number I can factor out. So I factor out a 2, and I end up with 16x squared minus 9. I can verify it. I did it correctly by distributing, attach x squared, distributing. I'm only going to be right now focused on this inside. This is a difference of squares. You've learned this freshman year. What does this mean? It means what two things multiply to give us 16, multiply to give us 9, and then x squared breaks into x and x. So 4x plus 3 and 4x minus 3 would be your two factors. And now we're asking ourselves, what are the two solutions that makes the right side equal to 0? I'm going to take each one of these and I'm going to set it equal to 0. So 4x plus 3 equals 0 and 4x minus 3 equals 0. And then I'll solve using algebra. How can you verify you did this correctly? Well, I have a quadratic equation here, and you can verify that these are the correct answers by going into Desmos and graphing this function. So graph this original function. Take out the 0 and put in a y. Graph this in Desmos. Remember, when you find the solutions, what's another word for solutions? 0. What's another one? Roots. Another one. X-intercepts. So when you graph this in Desmos, you're going to find out what are the x-intercepts. And they better be negative 0.75 and positive 0.75. That's the way you can verify, hey, you did it right. What if when you graph this, what if you don't get those two? Then you know you did something wrong and you want to go back and look at your work.